You're listening to The Conversation. One day in 1976, a school teacher is admitted to a small field hospital in Yambuku in the north of the Democratic Republic of Congo, then called Zaire. He's taken his class on a trip down the Ebola River and fallen ill, eventually dying from hemorrhaging and dehydration. The virus he caught spreads quickly in the hospital and nearby community, killing nearly 300 people. A blood sample from a dying nurse taken to Belgium for analysis shows a new worm-like pathogen. It would be called the Ebola Zaire virus, named after the river and the country. 50 years later, the Democratic Republic of Congo is now facing its 17th Ebola epidemic, this time centred in the eastern province of Ituri, where years of conflict, thousands of displaced people and poor health infrastructure make it particularly hard to fight.
The DRC, impoverished and racked by 3 decades of conflict in the east, has limited capacity to conduct laboratory tests to confirm cases.
The virus has circulated more than probably 6 or 8 weeks before even it was detected. It was really a way ahead. That's why now this is a catch-up.
As of June the 2nd, 61 people have died in this outbreak, and there have been 359 confirmed cases, including some in neighbouring Uganda. This epidemic is of a strain of Ebola called Bundibugyo, first identified in 2007 in Uganda. While there are 2 approved vaccines for the Zaire strain of Ebola, none currently exist for Bundibugyo. Why not? And what will it take to develop a vaccine against this new strain of Ebola? I'm Gemma Ware from The Conversation, a news and analysis platform partnering journalists with academics. Welcome to The Conversation Weekly, where experts explain how we ended up here. In this episode, the scientists racing to make a new Ebola vaccine. Theresa Lam, you're the Kaliva Head of Vaccine Immunology at the University of Oxford, where you've worked on a variety of different vaccines, including on Ebola. And Rebecca Makinson, you're a postdoctoral researcher working in Professor Lam's group. Welcome to the podcast, both of you.
Thank you so much. Happy to be here.
Thank you. Thanks for having us.
So it's been just under a month since a new Ebola epidemic was declared in the Eastern Democratic Republic of Congo, the DRC. Tell me, Rebecca, how dangerous is this moment?
Yeah, it's feeling pretty dangerous at the moment. So we are a little bit behind on the outbreak response as to where we've been in previous outbreaks. Initial testing on this outbreak was done on a different species of Ebola virus. So we missed that key initial moment where we identified the virus that's causing the disease. And we really didn't get the info that it was Bundibugyo until a good time later. And public health measures are really playing catch up here.
What do we know, Rebecca, about the Bundibugyo virus strain of Ebola that's causing this current epidemic?
When a lot of people talk about Ebola, they picture one virus, but it's actually a group of viruses. We call it a genus that has several species within there. And Bundibugyo is just one of them. So it was first identified in 2007. And that was in an outbreak in the Bundibugyo district of Western Uganda, which is where it gets its name from. But that was the first outbreak we'd seen of it. And before that, it really wasn't on the radar. And then since then, there's been another outbreak, and then this is the third that we've seen. Ecology-wise, there's actually a lot we still don't know. Like other Ebola viruses, Bundibugyo is considered a zoonotic pathogen. So that means it circulates in both animals and then occasionally spills over into humans. So the leading hypothesis that we have for this is that there's certain species of fruit bats that act as a natural reservoir. And we think this because related Ebola viruses have been linked to bats. We've seen viral genetic material there, but yeah, there's still a lot of work to be done on Bundibugyo. And yeah, I think really that's linked to the fact that this is its third major outbreak that we've seen.
When you look at this virus under a microscope, what's different about it to the Zaire strain?
Well, they're pretty similar in terms of that they're from the same group. So they're these filamentous or thread-like viruses. When you look at them under the microscope, a little bit like a shepherd's crook. And all members of this group, so the Zaire Ebola virus, the famous one that we've all heard of from the 2013 to 2016 outbreak, and also this and the other members, have this one surface expressed protein called the glycoprotein. So that's the same amongst them. But what's different is how related the glycoprotein is. So they are distinct species. Yes, they're related, but they're different. And when we look at what makes up the glycoprotein, so the amino acid sequence within the glycoprotein, how similar they are, we're only looking at around 60% between the two. So they behave similarly, similar ecology, but really we're not confident that a vaccine that we generate against one would be able to cross-protect against the other because of that difference in the sequence of the glycoprotein.
Have we tried using an existing vaccine against this one?
Yeah, so preclinically, the data's pretty limited. We've never tried in humans, which would obviously be the gold standard of data, but there have been a few limited preclinical studies where we've tried administering a vaccine against one and then challenging the animal. So that's when you purposely expose it to the disease and see if they get sick. We've tried that. So vaccinate against one, challenge with the other. And really, the data's limited, but it's not looking like we're getting great cross-protection here.
Let's talk about vaccines. Why is it so hard to make a vaccine for Ebola? What are the challenges involved?
Yeah, so I think surprisingly, challenge-wise isn't that we can't make one, because we can and we will. And we have previously, there's 2 vaccines that are licensed for use against Zaire Ebola virus, and they work exceedingly well. So the challenge isn't necessarily in like the biology of it. The main challenge is logistical and funding related. So unlike, say, flu or COVID, the Ebola viruses affect relatively few people globally, although the outbreaks are horrific. There's just really not that normal market incentive that you'd get for pharmaceutical companies. So vaccine development can be really expensive and there's limited commercial return. So much of the progress that we see when we're developing vaccines are depending on governments and non-profits and international organizations like the WHO to drive forward the development. So in that case, the other Ebola viruses that have caused more outbreaks do seem to have been prioritized here. So that's one challenge, the financial aspect. But there is also a practical challenge. Once we've had vaccines developed and approved for use, we see that these outbreaks often occur in regions with limited healthcare infrastructure. So once we've got a vaccine funded and then successfully made, we need to be able to manufacture it, transport it, store it, and get it to people quickly enough to be able to stop the transmission. So yeah, I'd say the question isn't really whether we can make an Ebola vaccine, because it's very clear that's possible. The big challenge is being able to develop these vaccines in peacetime, so when there's not an outbreak happening, and then making sure that they're available as and when and where the outbreaks occur.
So it's not perhaps got the same challenges as even, say, a malaria vaccine would have?
No, we're lucky in that sense that we've got a clear target here and a much less complex life cycle than, say, the malaria parasite does. All the vaccines use that glycoprotein on the cell surface. So yeah, we're not on the back foot there, as our colleagues in the malaria vaccine world struggle with.
So there are currently 2 vaccines licensed for Ebola, for the Zaire strain. Can you just describe how each one of those work and what they do differently?
Yeah, so they're both what's termed as a viral vector vaccine. So here we're using a non-infectious, non-dangerous virus. We then would delete the gene that gives them their cell surface protein, and we replace it with this glycoprotein that we've been talking about for Ebola virus. And you vaccinate with that. In no way are you ever being exposed to Ebola. It's not Ebola disease causing or disease causing at all. But then we use this viral vector to deliver the glycoprotein to our bodies, which are then able to make antibody and T cell responses against that protein. And both of them work that way. There's 2. One is a one shot, and the other one requires 2 doses to be effective.
Coming up, Rebecca's colleague Teresa Lamb explains how her team are using the same viral vector technology to develop a vaccine for the Bundibugyo strain of Ebola.
What are you going to have? Can I have 2 pieces of mullet, please? A piece of sea perch and 8 whiting fillets, please, Pauline.
From a fish and chip shop in regional Queensland
I believe we are in danger of being swamped by Asians.
to the heart of Australian politics, this is the unlikely story of the country's most controversial minor party.
Are you xenophobic? Please explain.
For 30 years, One Nation and Pauline Hanson have been ridiculed, dismissed and shut out.
Gone. I don't like it. No, I don't. Never did.
Now, no one's laughing.
One Nation continuing to surge in the polls.
Dramatic surge in support for One Nation.
The fringe becomes the mainstream.
This is the story of how a party built on fear and grievance thrived, died, and rose again to upend Australian politics.
Well, I'm back.
Hanson 2.0 is the serious, strategic, experienced, battle-hardened political operator that we see in the news today.
I'm Ashlyn McGee. This is The Making of One Nation from The Conversation, and you can search for it wherever you listen to podcasts.
Welcome back. Teresa, you and your team have been involved in making a vaccine candidate at Oxford against Ebola viruses, using the same viral vector technology used in the existing Ebola vaccines. Can you tell me about the history of this ChAdOx1 platform that you use and how it works?
Yes, ChAdOx is a platform that we've worked with for many years. It's a viral vectored platform, as Bex has already explained. What that means in plain English is we take a non-replicating, non-infectious virus that was originally isolated from chimpanzees, hence the Chad in it, and we change it ever so slightly from the COVID vaccine and for other vaccines that we're developing against other outbreak pathogens to almost act as a carrier or a Trojan horse that will carry in a very small message, a recipe, if you will, for the glycoprotein on the surface of the Ebola virus. And what that means is when we vaccinate with ChAdOx, your body starts to make this very small, minuscule part outside the surface protein of the virus that you're trying to target. So in this case, the glycoprotein of Bundibugyo. Your body has never seen this before, and it mounts a very strong immune response against it. The ChAdOx platform is the same platform that was used for the COVID AstraZeneca vaccine, where we, and I mean this in a very plural, we made more than 3 billion doses. It was licensed and released to over 180 countries. We've been working with this platform for at least 15 years, and there was a lot of research going on before that. So we've amassed a lot of information around how to make these vaccines, how to do it safely, and how to do it quickly.
And so in order to make it for this Bundibugyo virus strain, you need a little bit of that virus, do you?
You don't need anything from the virus itself. So what you need is the recipe, the sequence, the amino acids of the virus. And what we do is we take that small amount of information from the virus, the part that we think if you were to mount a strong immune response against, you would be protected. And we put that into our platform technology. So your body expresses a very small part of the outside of the virus, the glycoprotein, and in that way you mount an immune response against the virus.
So you used a version of this platform in an outbreak of Sudan Ebola virus, which is another strain of it in 2022. How did that go? How effective was that?
So we've had a number of outbreaks of filoviruses. I thought we would get a break after COVID, but I think it was a year and a half before the next outbreak happened that we all had to stand up again and start making vaccines for. Since COVID, we have been making vaccines against Sudan, Marburg, and now Bundibugyo, and we continue to make vaccines against many other infectious hemorrhagic fevers. Thankfully, in the outbreaks that we were involved in for the filovirus outbreak since 2020, public health measures meant that the outbreaks were contained and curtailed, and those vaccines were not needed in those outbreaks. So the vaccines were not deployed. As always, we're always very supportive and hopeful that the public health measures will actually curb this outbreak as well. At the moment, we need to be standing up vaccines, therapeutics, and other measures in case those public health measures don't actually stop the virus in its tracks.
You're now adapting it for Bundibugyo. Tell me what you're doing, what stage you're at, and what needs to happen next.
As with all outbreak scenarios, you tend to do a lot of things all at the same time. So typically when you're developing a vaccine, you will do 3 stages. There will be preclinical, where you assess that the vaccine is working in small animals. You will do manufacturing. That's where you will make the vaccine at a level that is suitable to go into humans after you've had good readouts from small animals, and then you will start your clinical trials. Because we are using a platform technology where we have amassed a lot of knowledge around how to make these types of vaccines, we're trying to run each of those different streams at the same time. For example, we've made preclinical lots of the vaccine. We're assessing them in small animals. At the same time, we are making the vaccine so that we can start the clinical trials, and we will continue to amass the data in that manner. So we are at the moment hoping to do a phase 1 relatively soon, and certainly faster than you would routinely do. And that phase 1 will certainly give us an indication of immunogenicity and also reactogenicity. We will, of course, prior to do that, set up some animal studies as well, as these are all needed.
Could it be in DRC or in Uganda, or it's unlikely?
So the phase 1 would typically not be done in an outbreak situation, no.
Okay.
We need to remember that at the moment, the DRC is it's quite a difficult scenario to run these types of trials, given the unrest we are seeing there. So that's what we're having to weigh up.
Yours is not the only route being tried at the moment to find quickly a vaccine for this Bundibugyo virus strain. What else is going on?
So there was a recent announcement that CEPI will be funding 3 different vaccine manufacturers to make some vaccines. One is obviously the Oxford Chadox vaccine. A second one is the Moderna mRNA vaccine. And the third is IAVI, the VSV platform. So truthfully, I'm hopeful that we all get successful vaccines and that we are in a good place where we don't need them, but we have them if they are needed.
What is a good efficacy for a vaccine like this in terms of Ebola?
So good efficacy for me is something that keeps you alive. So during COVID, I was asked which is the best vaccine. And my answer was generally, whatever one you're offered, put it in your arm if it keeps you alive. And they all did that.
Okay. Obviously, vaccines are only one part of the way to treat an Ebola outbreak. The public health measures are really important, and that is what the health workers in the DRC and Uganda who are dealing with this now are really thinking about. What is really important, and what have we learned from the previous outbreaks that they have to focus on now?
The type of protective equipment that you've got that will keep you safe while you're treating patients. I think there's a lot of social science needs to be at the forefront as well of our mind. I think we sometimes don't consider what is normal practice in other countries and therefore assume we know best. And we need to learn from our neighbours and the countries where these outbreaks happen, so that we are certainly not coming in and imposing a certain way of doing protective measures. I think it's also important to mention that Oxford is helping set up some therapeutic trials as well during this outbreak. So there's a lot of different types of interventions. And I think there's a lot of work that needs to be done about honestly representing what these vaccines can and can't do, and talking to the public to assuage concerns as well.
What do you mean what they can and can't do?
For example, during COVID, there was a misconception that vaccines would stop you from feeling ill. I think the first thing you focus on when you're making a vaccine is keeping people safe and keeping them alive. If you can lower the symptoms, that's great. But if you can't, you're still going to try and make a vaccine that will keep people alive. So there is sometimes a misconception that a vaccine is going to stop the spread, it's going to stop transmission, and it's going to keep you healthy all the way through an infection. So I think we just need to be honest around what we can and can't expect from these different types of vaccines.
What do you think are some of the real challenges in this epidemic about where it's happening?
I would say that one aspect that I probably hadn't thought about enough is contact tracing. I don't think that's going to be easy to do. And certainly when you're doing vaccine trials in these types of areas, the way that you typically do them is that you will vaccinate the contacts to try and keep people safe. But if you can't trace the contacts, you're not going to be able to vaccinate them. And it's also a part of the world where there is a lot of vaccine skepticism. So again, I think social scientists have a big role to play in this outbreak.
Why are there more epidemics of Ebola happening in the 21st century? Do we know?
So that's quite a complicated and very good question. Global warming in the sense that, and it's not just for Ebola outbreaks, it's lots of outbreaks of these types of hemorrhagic fevers or zoonotic diseases. And as we are encroaching into habitats that we don't always see humans in, there's something to be said about detection as well, in that we are at least able to detect when we put our mind to it and develop the diagnostics more rapidly. And then I'd hand over to Bex to see if there's anything she'd like to add.
Totally agree with everything Tess said. Global warming encroaching on animal habitats, with that, the urbanization that we're having, and also, I guess, a lot more mobility now than we'd had previously. So that's potentially not causing an increase in the outbreaks, but it is adding extra considerations into how we manage them. There's a lot of very porous borders and very essential movement that happens in these countries, which is really contributing to the public health measures of how we stop it spreading into neighbouring countries. Obviously, we don't want to be, we all remember from COVID, when we were all under lockdowns, we don't want to be restricting movement where we can avoid it.
The fact that this was only named in 2007 means that it's a new strain that's emerged fairly recently. Do you think it's likely that in the next 10, 20 years we might see more of these different named strains?
Yeah, I wouldn't rule it out. There's a lot going on in bats that we don't know about. A lot of scientists working on doing serosurveys in bats to try and pick this information up. But yeah, I think that's a real possibility.
Okay. Well, thank you so much, both of you. Good luck with your efforts. We hope they are fruitful and that they save lives, as I'm sure you do. Thank you very much.
Thank you. Have a lovely day.
Thank you.
That's it for this week's episode of The Conversation Weekly. You can read more analysis of the ongoing Ebola epidemic in The Conversation, and we'll put some links to further reading in our episode description. We'll also put in a link to an article by the researcher Derek Gatherer about the history of Ebola outbreaks in Africa, and that includes a bit more detail about the first Ebola outbreak mentioned in the introduction to this episode. This episode was written and produced by me, Gemma Ware, Menda Marawani and Katie Flood. Sound mixing is by Elena Brezzi and our theme music is by Nita Saal. Special thanks to Wale Fatadi and Caroline Southey at The Conversation Africa. The Conversation is a non-profit news outlet dedicated to sharing the work of academic experts with a wider audience. If you like what we do, please consider supporting us at donate.theconversation.com. Thanks for listening.
Hello, curious kids. Have you ever wondered how high a volcano can throw lava in the air? Or
why is it that when you're in a bath your fingers go wrinkly?
Or even,
will scientists be able to make a new element?
Well, you're in the right place. I'm Eloise and welcome back to Season 2 of The Conversation's Curious Kids, the podcast where an expert answers some of your most head-scratching questions. Listen to The Conversation's Curious Kids wherever you get your podcasts. New episodes every Tuesday from the 9th of June.